Hi guys, it's Ms Wisz. Mrs. Muller and I will be back tomorrow. We're very excited to be back. So you have one more day of a video lesson. So hopefully you have your stamp sheet out. And write down tonight's homework. We're going to be solving logarithmic equations today. So a little different from what you've been doing the last 2 days. And I would like you to go ahead and turn in your homework. And so Isaac or Casey or Dylan will be stamping your homework, and they know that process with the folders. So go ahead and put your homework in the folders. If you need to pause the video to do that, go ahead and do that. And then once the homework has been in the folders, we're just going to do our lesson. And you guys are going to have the homework in front of you as we go through the lesson, because we're going to be doing a lot of your homework problems together. And then you'll just have some time to finish up the homework in class. Okay, here we go. So we've been talking a lot about logarithms, and by now I hope you know the answer to this question. What is a logarithm? A logarithm is an exponent. I'm going to apologize right now. I'm using the Mobi, not writing on the board, so it's going to be a little bit sloppy. Okay, logarithm is an exponent. And when do we use them? We use them to take the inverse of an exponential equation, right? Okay, so let's do a quick review of a few of the properties that you should be comfortable using by now. So the first is the power to a power, right? So if we have the log of something being raised to a power, we can bring that power down in front and multiply it by the log. So that's the first one. The second one, we've turned it around on you today. We've seen it the other way the last few days. But so if you have the log of two things being multiplied, that's the same thing as log of one of the terms plus the log of the second term. And today, rather than, so we've been going this direction, and we're also going to need to go this direction today. And then the last property is the quotient property. So if you have the log of two things being subtracted, or the log of m minus the log of m, we can write that as the log of m divided by n. Okay, and remember these all are coming from our exponent property. Okay, so you guys are going to be able to solve equations that have logs in them already. And we'll see what that looks like in a second. If you don't already have the homework in front of you, let's make sure that gets passed out so that you have the homework. Should be day 14. Okay, so let's start looking at two different equations. These are both called logarithmic equations because they have logs in them. So we're not going to use the log of both sides to undo exponential. We already have logs. So to get rid of logs, we're going to have to use exponential. But let's look. Some of this we already know. So this first one, we have log base 5 of x is 2. So you guys are very good by now at rewriting an exponential equation into, or excuse me, a logarithmic equation into exponential form. So we have log base 5 to the second power gives us x, right? So in this one, you guys already know how to solve this equation. So x is just 25. And we could check that, right? That's saying 5 to what power is 2? All right, excuse me. 5 to what power will give you this number? 5 to the second power will give you 25. Okay, so that one we didn't have to take the log of both sides or anything like that. We could just rewrite it in exponential form. Let's look at this second equation. We haven't ever done something like this. This one is not so easy to write in exponential form. However, this is basically saying we have the log of something. So 5 to some power gives us x. This is saying 5 to some power gives us x. And this side is saying 5 to some power gives us 25. So basically it's saying that x is 25, right? Since we have the same thing on both sides, we have log base 5 here, and we have log base 5 here. We basically don't have to even consider the logs, and we're just saying that x is 25. Right? So in this case, it didn't really help us to rewrite it in exponential form because we're just considering when are the two the two parts of the log, so the x and the 25, when are those equal? Well, when x is 25. Okay, so that brings us to two types of problems we're going to see today. We're going to see one type where there's a log only on one side. When that happens, you're going to rewrite it in exponential form just like we did. Second type is when we have logs on both sides. And when that happens, we're going to essentially ignore the logs and just set the two inside parts equal. Okay. So this is a good screen. These are kind of your notes for today. It's a good time to probably pause and write this down somewhere. Okay, hopefully you had time to write this down. Now we're going to use this to solve some problems. So let's look at this first problem. This is number 1 on your homework. First, we're going to look at it and see what we know. Well, we know a lot of properties that will help us condense. So that's step 1. We want to condense when we can, put things together. So on this side, we have log base 3 of 5 plus log base 3 of x. And we know from the past couple days, we can rewrite that as log base 3 of 5x. Right, that's using that product property. Okay, and I'm not going to change the right side. It's already as condensed as it can be for right now. Well, now we have the type of problem where we have logs with the same base. They're both log base 3 on both sides. So essentially we're just saying basically the same thing. So all we need to know is when is 5x equal to 10. We can figure that out. That means x is 2. If we were to substitute it back in, we'd have log base 3 of 5 times 2, which is 10, equals log base 3 of 10. So that's saying log base 3 of 10 equals log base 3 of 10. It checks out. Not so bad, right? Okay. Let's look at number 7. So go ahead and skip down to number 7. So number 7, first thing I notice is that these logs don't have bases. I hope you all remember that that means it's really a base 10. All right, we want to try to condense and then see where that leaves us. So on this side, I see two different logs. They're the same base though, so we can condense them into log base 10. You don't have to write this 10. Since they're being subtracted, that's the quotient property, 16 divided by 2x. This side's already condensed. I'm going to leave that alone. All right, so essentially we're saying all we care about is when are these two going to be equal, because we already have log 10, that's the same. So all we're really trying to figure out is when will these be equal. So to solve something like this, just an algebra 1 equation, multiply both sides by 2x over 1. 16 equals 4x. Divide by 4 on both sides, x must be 4. Okay. So again, we were using this. We had logs with the same base on both sides. Okay, I'm going to jump around a little bit. So let's go to number 13 next. We'll come back to some of these. Okay, so number 13 is really asking us to apply everything we know about exponents. So let's start with condensing with our property. So on this side, I have two logs. Let's try to condense them into one log. So the first thing I'm going to do is use my power to a power property. These coefficients can be brought up as exponents, right? So we'd have log base 2 of x, leaving the left side alone. And then rewriting this side. Bringing up the 1/4 as an exponent. And bringing up the 1/2. Okay. So now let's see what we can do from here. We could combine these into one log. But we also can simplify. I guess we can go ahead and combine. So we'd have log base 2, they're being added, right? So we can write this as 16 to the 1/4 plus 49 to the 1/2. Oops, I'm sorry. Multiplication, not addition here. Okay, and now let's see what this is. There's a lot of simplifying we can do here, right? 16 to the 1/4 power is something we should know. That's 2. And 49 to the 1/2 power, that's just saying the square root of 49, so that's 7. And we're in this case again, we have logs on both sides. So really, all we care about, since we have log base 2, we just want to make sure that these are equivalent, so that the equation is equivalent. So x equals 2 times 7, well, that's just 14. So x is 14. Okay, so you see how these are kind of puzzles. You really know a lot, and you just have to put it all together. Go slow, step by step. What do I know? What do I know? And eventually you'll get down until you get the answer. Okay, so we're going to skip over, let's see, we're going to skip backwards. Let's go to number 9. All right, so number 9, you can already see that it's going to put us in this other situation. We're not going to have logs on both sides. We only have logs on one side. We have logs on the left, not on the right. So we're going to have to eventually rewrite it in exponential form to get our answer. So let's start with step 1. Let's condense where we can. So here we can condense. We have log base 4. We have addition here, so we can rewrite this as multiplication. So we have x times, now this is a little tricky, right? We're going to have to distribute. I'm going to put in an extra set of parentheses just so we don't forget. Okay, so really we have log base 4 of, distributing here, x squared minus 6x equals 2. Okay, now we don't have log on both sides, so we can't just automatically ignore the logs. Let's use what we know, though. We know a lot, right? We know that a log is an exponent. If we were to read this, it would say log base 4 of something is 2. So it's saying 4 to some power is x squared minus 6, right? Well, we actually know what that power is, because it's an equation. It's telling us over here our power is 2. So it's saying 4 to the second power is x squared minus 6x. Right? So rewriting that, we have 16 equals x squared minus 6x. It's a quadratic equation, something we know how to solve. I'm going to subtract 16 to both sides. So we have 0 equals x squared minus 6x minus 16. We're going to factor to figure out our x. So we're going to get 2 x's here. But maybe we'll have to see if they both work, or if one of them is maybe an excluded value. So 2 things that multiply to 16, 8 and 2. The bigger one's going to have to be negative to add to a negative 6. So our solutions are going to be x equals negative 2. If we were to set this equal to 0. Setting this equal to 0, right? Add 8 to the other side, we get x equals 8. Okay, so we have 2 solutions. But let's check them. Make sure that they work. So if we come back up here, let's just check them into part of the equation. I don't even have to go very far. This is saying log base 4 of 8, the rest of the equation plus so on. Let's look at this one, log base 4 of negative 2, plus so on and so on, right? Okay, so could we raise 4 to some power and get 8? Yes, we could. We could do that on a calculator. It would be a decimal. So that one's okay. That's definitely a solution. It doesn't give us an excluded value. Let's look at this one, though. Can you raise 4 to some power and get a negative number? That's basically saying 4 to what power, right? So how many 4s do I have to multiply to get to -2. It's impossible to take positive numbers and multiply all positive numbers and get a negative number. So because of this, -2 is not a solution. So something you need to look out for, an important rule, is that log has to always be a positive number in here. So this part has to be greater than 0. Okay, so something to look out for. So in this case, we only have one solution, x equals 8. It's possible to have two solutions, but sometimes when you get to one of them, really isn't a solution. Okay, I think we need to do one last problem, and then I'll let you guys go and let you work together. Let's look at number 5. All right, number 5, we have natural logs, ln. So I can already tell I only have ln's on one side, so I am in this situation, right? We have logs on one side. We're going to have to use our exponential form to help us. Okay, so let's go ahead and condense. ln of x plus ln of 3x means I can go ahead and multiply x times 3x and write it as one natural log. All right, and then we need to use our knowledge of what the base is. Oops, I'm sorry, don't know what happened there. The base of this is really log base e, right? So let's use our knowledge of rewriting it in exponential form. So we have e to the 12th, or e to some power, equals this, x times 3x. Well, it's telling us that the exponent is 12. So we know e to the 12th equals, I'm going to rewrite this as 3x squared. Remember, e to the 12th is just a number we can figure out on our calculator. So we're going to end up dividing by 3 to get x by itself. And then we're going to square root both sides. So you end up getting x is approximately, in this case we have plus or minus, because we took the square root, 232, going 3 decimal places, 0.920. Right? Just doing this on the calculator. But remember, we can't have a negative, as you can't take the log of a negative number. So even though when we take the square root we get plus or minus, we really can't have minus. So our answer is really just positive 232, 90. Oops, 920. So the negative is not a solution. Okay, so I hope that's enough to get you guys started. It's a lot of playing, right? So please work together, really help each other. The top of the worksheet on both sides has an answer bank. So please check your work as you go, and the sub has the answer key as well. So use that, and good luck, and I can't wait to see you guys tomorrow.